Hi and welcome to my index laws examples video. So I'm going to take you through 4 examples. It doesn't cover everything, but it should give pretty good coverage to most of the concepts we talked about in the last video, the index laws. So first of all, 2 over 3 to the power of negative 1. This is by far my easiest example, but it just demonstrates the power of that negative indice. So if you have a negative power, that means that you will reciprocate the term on the inside, so it becomes 3 over 2, and then it just becomes 3 over 2 to the power of 1. Now, because it's to the power of 1, I can just write this down as 3 over 2. Remember, if you're just talking about a number to the power of negative 1, well, that number could be written as the number over 1, which would make it 1 over 7 to the power of 1 in this example. That's example 1. In example 2, I'm now dealing with some of index laws 1, 2 and 3 as we go, as well as mixing numbers and algebra. So first of all, we've got 3 distinct terms that we have to simplify. So let's first simplify those 3 distinct terms. The first term, everything inside the brackets is squared. Negative 2 squared, I hope you understand, is 4. If you square a negative number, you get a positive number. I get 4x squared, y squared. So the x is squared and the y is squared, multiplied by, in this case the 2 is on the outside of the brackets, so it just remains 2, and then I get x to the power of 6, because it's x squared cubed. This is x squared cubed, and y to the power of 3 for the same reason. And on the denominator, I have an 8, and the 8 is outside the bracket, so it's not being acted on. And of course I end up with 8x cubed, y cubed. Now, before I can simplify the fractional component, I have 2 terms on top I'd like to simplify first. So I'm going to write this down. I'm going to leave my denominator the same, 8x cubed, y cubed. But I'm going to work on my numerator. 4 times 2, first of all. So I'm going to multiply the numeric values. 4 times 2 is 8. And then x squared times by x to the power of 6. And that is x to the power of 8. Remember the law, a to the power of m times a to the power of n is equal to a to the power of m plus n. And then y squared times y to the power of 3, and I get y to the power of 5. Same law. Now again, I'm going to simplify my top and my bottom numerically and then by the algebra. So first of all, the 8 and the 8 cancel out. That's nice. And then I'm left with x to the power of 5. This is because of index law 4, which is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So 8 minus 3 is 5, and y squared. And that's my final answer, as simple as possible. My next example is a numerical example, and you'll notice here that we have an issue. The bases are not equivalent. Now, in non-contextual questions where you're being asked to test your skills and practice your skills, you could probably make the loose assumption here that there is going to be some relationship between the bases and what you're trying to do. So, let's imagine I wrote down all the powers of 2. And the powers of single numbers are going to be really important. So first of all, 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 squared is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. And 2 to the power of 5 is 32. Now I could keep on going, but I recognise now that I've got 32, 2, 4 and 8. 32, 2, 4 and 8. So those numbers are all actually powers of 2. If you get numbers where the bases are different, you might need to look at whether they are actually powers of a simpler base. I'm now going to convert all of my numbers into the simplest possible base, and that is base 2. So I now get 2 squared to the power of n instead of 4 to the power of n. times 2 cubed to the power of n plus 1 instead of 8 to the power of n plus 1 over 2 cubed times 2 to the power of 5 to the power of n. Expand my brackets using the rule that a to the power of m to the power of n equals a to the power of mn, and that gives me 2 to the power of 2n times 2 to the power of 3n plus 3 all over 2 to the power of 3 times 2 to the power of 5n. And this, of course, is equal to, remember, I add my powers together when I'm multiplying index numbers. So I end up with 2 to the power of 2n plus 3n plus 3 over 2 to the power of 3 plus 5n. And I'll just write this down simplified. 2 to the power of 5n plus 3 over 2 to the power of 5n plus 3. And that's pretty amazing, because now when I divide index numbers, I subtract the powers as long as the base is the same. 5n plus 3 minus 5n plus 3, and that gives me 2 to the power of 0, which gives me 1. So that's a very nice question that ends with a nice answer. Moving on from that, I've got one more question left where I have put in some rational powers and some square root signs. So in this case, you'll need to recognise I can deal with the fractional and the whole number powers, and I can use index laws 3 to 5 to simplify these. But I do have trouble dealing with those square root signs. So I'm going to change the square root signs. So instead of the fifth root of a squared, I'm going to write it down as a to the power of 2 over 5. Remember, that fifth root is my denominator of my fractional form. To the power of 3 over 2 times, in this case, a to the power of 5 over 3. That root, the number that's in the root sign, is the denominator. The power of a fifth. And now I'm going to multiply and simplify these. I get a to the power of 2 fifths times 3 over 2 times a to the power of 5 thirds times 1 over 5. And that gives me a to the power of 3 over 5 times a to the power of 1 over 3. So again, you might need to go back and look at some fractional work to help you deal with these questions, multiplying, adding, subtracting and dividing fractions. And of course, when I multiply two powers that have the same base, I add the powers, giving me a to the power of 3 fifths plus 1 third. I'm not really typically testing fraction works in these questions, so you could probably use a calculator. Remember, 3 fifths plus 1 third, we need the same denominator, so I'm going to write this down as 9 fifteenths plus 5 fifteenths, and that gives me 14 fifteenths. So it's equal to a to the power of 14 fifteenths, or the 15th root of a to the power of 14. Whichever of those two forms is more appropriate for the question. Well, I hope that was helpful. Thank you very much.